Okay, good evening Dr. Dayang and Dr. Rosita. We are from H.O.T Consultancy, and first of all, I'd like to introduce my members. I am Harbin Singh and Anakin Singh, matric number 187207.
My name is Muhammad Nur Fitri bin Mustaza. My matric number 189946.
My name is Tan Jomi. My matric number is 188286.
For the introduction part, the task given to us was to design a process that produced a thick solution from a suitable raw material. The process solution that we chose was by using extraction and treatment process to produce thick juice of sugar syrup. Next, what is the raw material? The raw material that we chose was the sugar beet plant. This is because it has the highest concentration of sugar sucrose compared to other plants, which is around 16 to 17%. It is easier to extract and treat beet sugar. The composition of sugar beet is around 65.6% of water, 16.5% of sugar, and remaining 70.9% of pulp, salt, and reduced sugar with ash. Okay, next, the production rate and specification. The production rate of thick juice solution per annum is 15,000 ton, and then the production rate of thick juice solution reduced to per hour is 1.89394 ton. The thick juice solution concentration is 65 brix, which is 65% sucrose and 35% water. Okay, this is the process flow diagram of the design project with the label stream down here. Okay, start up with cleaner, then next unit of operation is slicer here, then this is the diffuser and extractor tower right here. This is the pressure heater before the clarifier. Next we go on into the filtration here, over here, filtrate the solid particles as filter cake and beet juice. Then here is the evaporation to thicken the juice. Okay, that's all the process flow diagram. So the temperature and pressure are labeled over here, and they are also stated at the below stream. Okay, the process description. We start out with cleaning. Okay, the purpose of cleaning is to clean the sugar beet from soil and dust particles. The assumption we made is all of the soil particles are removed with 2% of the washing water is included in the output stream. First of all, the input stream contains around 7,498.47 kg per hour, while the output stream contains around 7,573.45 kg per hour, which included 2% of the washing water. Next is slicing. Okay, the purpose of slicing is to slice the sugar beet into tiny chips to increase the surface area for diffusion. The efficiency of unit is 1, which means all the input mass flow rate will be also the output. Okay, the input mass flow rate of this unit operation is 7,573.45 kg per hour. Okay, next unit operation is diffuser and extractor. The efficiency of this unit is 0.9%, and then 200% of water based on 100% input at 70 degrees Celsius is put in the diffuser. The sugar beet juice is extracted using the method of counter current flow of water towards the beet pulp, and then 90% of juice extracted is flowed to the heater, while 90% of solid pulp is subjected to the pressure because of the 0.9% efficiency. The flow rate at the input is 7,573.45 kg per hour, while the flow rate at the output is 3,260.03 kg per hour.
In the presser, the beet pulp is stilled from the diffuser and some of the sugar. The efficiency of the presser is 1. The input of the presser is 3,260 at the temperature of 70 degrees Celsius, and then the stream 6 and 7 will combine and at the mix point, so the output will become the 21,557.01 at the temperature of 80 degrees Celsius. In the clarifier is to remove impurities and solid particles. The efficiency of the clarifier is 0.9. We assume that 90% of the solid impurities are removed, 100% of CaCO3 is removed, and 20% of water is removed. The input to the clarifier is 21,557 at the temperature of 80 degrees Celsius, and the output of the clarifier is 17,372.59 at the temperature of 80 degrees Celsius. The calcium oxide that we use is 1.664, and the calcium carbonate that we use is 1.278. The process that we use in the clarifier is carbonation. The purpose of using the carbonation is because that it can coagulate the reducing sugar and purify the juice and make the juice become clear. Next, in the filtration is to filter all the solid particles from the juice and produce a clear thin juice. The efficiency of the filtration, we assume that it is 1. The input to the filtration is, input to the filter is 17,372.59 at the temperature of 80 degrees Celsius, and the output of the filter is 17,354.68 at the temperature of 80 degrees Celsius. Next, in the evaporator is to concentrate and thicken the thin juice. To produce 65 bricks of sucrose, which contains 65% sucrose and 35% of water. The input of the evaporator is 17,354.68 at the temperature of 80 degrees Celsius, and the output of the evaporator is 1893.94 at the temperature of 90 degrees Celsius. The flow rate of the stream in is 474.22, which is same with the stream out. The temperature of the stream in is 130 degrees Celsius at the 230 kilopascal, while the stream out at the temperature of 130 degrees Celsius and the pressure is 101 kilopascal.
I would like to explain about the total capital costing, which include as the following. Okay, for the inside battery limit, we are going to calculate the major process equipment. This is the price for each equipment, and each of the price will be times with the transport percentage from shipping, which is 5%. So the 5% is this amount for the delivery. So we are going to get the total cost from every sum of the major process equipment and including the delivery. After that, we are going to times it with the length factor, which is 3.89. So we will get the estimated ISBL, which is 834,000 ringgit Malaysia. Okay, now we will calculate the outside battery limit, which is 40% of the ISBL. Next, for the design and engineering, we will need 20% of the sum from ISBL and OSBL. Next, for the contingency, is include 10% of ISBL plus OSBL. For the total fixed capital cost, is the sum of ISBL, OSBL, design and engineering with contingency. Then we will calculate the estimating working capital, which is 15% of the total capital cost. And lastly, for the total investment that required for this project is RM 1,746,000. Next, we are going to talk about the operating costs, which include the variable cost and fixed cost. Okay, first we are going to talk about the variable cost, which include the raw material and utilities. The raw material we are going to use are sugar beet, calcium oxide, and calcium carbonate, and utilities such as water. For the usage of 1 year, we are going to need RM 7,310,000 for just the variable cost. Next, we are going to talk about the fixed cost. For the maintenance, it is 5% from the total fixed capital. For labor, plant, overhead, and laboratory, it is from the 20% of operating cost, and the capital charge is 13% of total fixed capital. Therefore, the total operating cost for this project is
9,500,000. That is the estimating cost. Next is the cash flow. This is the cash flow for our design, which include from 0 year to 20 years ahead. From the graph shown, after the 4th year, we are going to gain our profit, which overcome the money need for the investment. Therefore, during the 4 to 20 years, we already gain our profit.
Use is cleaning, slicing, extractor, diffuser, presser, clarifier, such as especially the carbonation, filtration, and evaporation. To produce 15,000 ton thick sugar solution per annum, the total capital cost is around 1.5 million ringgit Malaysia, and the total operating cost is around 9 million ringgit Malaysia. So the total amount cost of our design is 10 million ringgit Malaysia. Here are some recommendations. First, using the coarse cutter knife and recycling the pressed water. Lastly, use a small amount of SO2 after filtration to prevent the darkening of juice.